consider the structure Zn together with multiplication modulo n. Here, Zn is the set of all remainders upon division by n. 0, 1, 2, and so on up to n minus 1. Question: is Zn together with multiplication modulo n associative? Answer: yes. Let's exemplify. Example: in the structure Z8 together with multiplication modulo 8, show that the quantity 5 times 6 multiplied by 7 equals 5 times the quantity 6 times 7. Let's show this by performing the two calculations and showing that the answers are equal. So let's compute. On the one hand, the quantity 5 times 6 multiplied by 7. Let's find the answers to that. On the other hand, let's compute 5 times the quantity 6 times 7. Now, here the multiplication is multiplication modulo 8. So let's begin. 5 multiplied by 6 modulo 8. Normal multiplication of 5 and 6 gives you 30. But what is the remainder when we divide 30 by 8? 6. So 5 times 6 multiplication modulo 8 is 6. So here is our result, our partial result. 6 times 7, where the multiplication is multiplication modulo 8. Now, normal multiplication of 6 times 7 is 42. When we divide by 8, the remainder is 2. So 6 times 7, where the multiplication is modulo 8, results in 2. Now, our second calculation. We have to follow our order of operations. What's inside the parentheses must be computed first. So what is 6 times 7, where the multiplication is multiplication modulo 8? Well, we already know the answer to that was 2. So now we obtain 5 multiplied by 2, multiplication modulo 8. Now, normal multiplication of 5 and 2 gives us 10. But when we divide by 8, remainder is 2. So final result is 2. So confirmed. So therefore, the quantity 5 times 6 multiplied by 7 equals to 5 times the quantity 6 times 7. Now, we want to prove this in general. The structure Zn together with multiplication modulo n is associative. Okay, so now we prove that the structure Zn with multiplication modulo n is associative in general. Let A, B, C be elements in Zn. Let the product modulo n of AB be R1, and let the product of BC, the product modulo n of BC be R2. Let A, B, C be elements in Zn. Also let the product modulo n of A and B be equal to R1, where R1 is a remainder modulo n. So R1 belongs to Zn. Also let the product modulo n of B and C equal to R2. Okay, here is our goal. Show that. Here is our goal. Show that the quantity of A dot B times C equals to A times B dot C. We're going to work this via our definition of multiplication modulo n. Here we have two multiplications modulo n. What is the meaning of multiplication modulo n? Well, for our first equality, that means that AB is congruent to R1 modulo n. So AB is congruent to R1 modulo n. Let me repeat. This is a product modulo n. What is the meaning of this product? It means that A multiplied by B is congruent to R1 modulo n. So this is by definition of multiplication modulo n. Similarly, in our second equality, by definition that means that BC, this is normal multiplication of integers, is congruent to R2 modulo n. Now let's make the following observation. When we're looking for this product, modulo n, we would like to have the result of AB multiplied by C. Now, that can be achieved in our definition, in our congruence. Let's just take the first congruence and multiply it by C. So you have AB, the quantity AB multiplied by C is congruent to R1 multiplied by C. Now that's a valid step because when we have a congruence, if we multiply both sides by the same quantity, we still get congruence. Now, in our second congruence, where BC is congruent to R2 mod n, let me multiply both sides by A. Multiply by A on both sides. Now, observe. These are multiplications of integers. These are normal multiplications of integers. So we know that multiplication of integers is associative. So since the structure Z with multiplication in Z is associative, then these two quantities, these two expressions are equal. So the quantity A, B times C equals to A times the quantity BC. So now observe, P is congruent to Q. Q is congruent to T. Therefore, P is congruent to T. This is the transitive property of congruence. So by the transitive property, comma, R1C is congruent to AR2 modulo n. Now let's put this as a product modulo n. So by definition, this means, what you see here means that the product modulo n of R1 and C equals the product modulo n of A in R2. But wait a minute, I know what R1 is. R1 is the product modulo n of A and B. Similarly, I know that R2 is the product modulo n of B and C. So observe then that the quantity A dot B multiplied by C equals to A dot the quantity B dot C. In other words, our goal. So therefore, the quantity of A times B multiplied by C equals to A multiplied by the quantity B times C, and we are done. So let's look at the summary of what we did. And that's all for now.